What if I told you we're living inside a black hole right now? I mean everything, me, you, the galaxies, the whole observable universe, inside one. Sounds like science fiction, right? But new data from the James Webb Space Telescope suggests it might actually be true. And if it is, the consequences are huge. It would mean the Big Bang wasn't what we thought at all. It may have been a white hole. So let's go through what that means. The collapse of a star into a black hole and the expansion we call the Big Bang are both solutions to Einstein's equations. In both cases, density and space-time curvature shoot off to infinity, and classical physics no longer works. That's where weird results show up. Because of this, some scientists started asking, what if these two phenomena are really just two versions of the same thing? First similarity, the singularity. At the beginning of the universe, everything was crushed into a single, infinitely dense point. That's where the Big Bang came from. Black holes also have singularities of infinite density, but theirs sit inside the black hole instead of at the start of time. Second similarity, horizons. A black hole has an event horizon, a spherical boundary around the singularity that you can't escape once you pass through. Our visible universe has something very similar, the particle horizon. It marks the farthest distance from which light could have reached us since the Big Bang. Nothing can come in from outside that, and nothing can leave a black hole's event horizon. They mirror each other. And this isn't just a vague resemblance. If you take the math for a black hole's event horizon and plug in the total mass of the observable universe, the size of the horizon matches perfectly with the cosmic horizon we see today. This connection was first noticed about 50 years ago. That led to the idea that the Big Bang was really a white hole eruption inside another universe's black hole. A white hole is the opposite of a black hole. Everything is forced out. Nothing can go in. This whole idea forms what's called black hole cosmology. It says everything we know, every star, planet, and galaxy is inside some massive black hole. The particle horizon we see is actually the event horizon of that parent black hole. Okay, now to what JWST found. But before that, you need to know about the cosmological principle. It says that if you zoom out enough, the universe should look the same no matter where you look. It should be homogeneous. Two random regions of space should have about the same number of galaxies in them. And it should be isotropic, meaning the sky looks roughly the same in all directions. No gaps, no weird patches. This principle is at the heart of cosmology. All observations in the past confirmed it, until possibly now. A recent study looked at 263 spiral galaxies far, far away. They counted how many rotated clockwise and how many rotated anti-clockwise. If the cosmological principle holds, it should be half and half. But JWST found 2/3 spinning clockwise and only 1/3 anti-clockwise. The author suggested this might point to black hole cosmology. Black holes spin. So if a universe is born inside a black hole, it should inherit that spin. That could explain why there's a preference for galaxies rotating clockwise. If this kind of mind-bending science fascinates you, make sure to hit subscribe so you don't miss the next discovery we cover. Yes, black holes can spin. In fact, most do. There are two main types: Schwarzschild black holes, which don't spin, and Kerr black holes, which do. Kerr black holes drag space-time itself as they rotate. Any matter falling in gets caught up in that spin. Later, when that matter turns into galaxies, they'll share the same spin direction. That might explain JWST's galaxy results. And here's where it ties to the Big Bang. Inside a rotating black hole, the singularity isn't just a point anymore. It becomes a ring. That ring leaves a tiny gap that, in theory, something could pass through. The exit is a white hole. And from the inside, it would look exactly like space suddenly expanding. That lines up perfectly with what we describe as the Big Bang. So, if the Big Bang was really a white hole event, how could we tell the difference? The key would be little irregularities. Our Big Bang inflation model should smooth out everything so the cosmological principle holds. But if the universe came from a white hole, it would leave behind telltale signs, like unusual galaxy spins or odd clumping of matter. That might be what JWST is picking up. But to be sure, we need more data. If this is really the case, then the black hole we're inside is unimaginably big. It would be about 46 trillion times the mass of the Sun. Its event horizon would stretch about 14 billion light-years. To put that in perspective, if the black hole in the center of our galaxy, Sagittarius A, were the size of a virus, then the black hole containing our universe would be the size of Earth. And this leads to a bigger possibility: universes inside universes. If black holes create baby universes, and each of those creates its own black holes, then you'd have a chain of universes reproducing. The ones that generate the most black holes last the longest. It's like natural selection, but with universes instead of animals. But hold on, this is far from confirmed. The study only looked at about 300 galaxies, which is nothing compared to the trillions out there. And the section of sky they studied was tiny, about the size of a pinhead held at arm's length. Also in the past, similar galaxy asymmetry results were explained as observational bias. Things like Earth's motion messing up the data. So right now, this is more of an open question. We definitely need larger sky surveys to know for sure, but the idea that we might actually be inside a black hole isn't just fantasy. It's a genuine scientific possibility supported by real physics. So are we living inside a black hole? The evidence is still unfolding, but one thing's certain. Space is stranger than fiction. If you want to keep exploring these mysteries with me, hit subscribe to Space Science Simplified and join the journey.